Good afternoon.
Good afternoon, sir.
Shall I start? Okay, I'll start. We have discussed the theory part. We have discussed how the shear force and bending moment varies. It is linear, constant, slope moving upwards, slope moving downwards. We will discuss all these cases. Now we will go ahead to solve the problem. And how the problem has to be solved, we will ask in the problem, find the reactions at the fixed end and draw the shear force diagram and bending moment diagram for the cantilever beam loaded as shown in figure. Generally, these problems can be of 8 marks, sometimes 16 marks, that is 20 out of 20 marks, 2 problems of 10 marks, something like that, depending upon the complexity you will ask. So what I will do in the exam, this is since I have lesser space here, I am doing like this. But I will send you how I have done in that way. You should solve the examination. You should make your sheet as landscape. You should rotate your booklet and you should solve. Okay, then it will be very easy for you. First problem. Is given a cantilever beam. This is point A, point B, point C, point D, point E, point F. B to C, there is a uniformly distributed load of magnitude 20 kilonewton per meter. There is a moment of 20 kilonewton meter. This is meter kilonewton meter. This is kilonewton per meter. This is 15 kilonewton. Okay. The length between A and B is 0.5 meter. B and C is 0.5. C and D is 0.5. D and D is 0.5. E and F is 0.5. Okay. Now, uh, first what we should do, I'll, okay, give me a moment. I'll find the reactions here. Okay, first you should write portion, figure, figure. Yes, Raghavendra, what's up, Raghavendra? What happened? Raghavendra, you raise your hand, right? Regarding what? Any doubts? Raghavendra,
Sir,
your
to ask about labs, sir.
labs. Okay, you remind me like at the end of the class.
Okay, sir.
Okay. portion, figure, and then shear force diagram and bending moment diagram. We should divide like this. Okay, portion. When I say portion, this is between 2 points, point A and point B and point C, point C and point D, point D and point E, point E and point F. First, I will take portion, portion AB. This region is x greater than 0, isn't it? X should be greater than 0 or less than or equal to zero point 0.5. Portion AB, x should, this is 0, x should be greater than a 0 or less than zero point 0.5 is a portion AB. Then, in this portion AB, I will take the suction. Before that, I should find the reaction. Sorry, I forgot to write. Reaction force. I'll write the always you should find the reaction force. Without reaction force, we should not solve directly like this. I will take reaction RA. I will take moment any direction you want to take. Finally, you will get correct direction. I will take moment in anti-clockwise direction. According to, we know that summation of force in vertical direction is 0, or RA minus 20 into zero point 0.5, it's minus 10. Hope you're understanding. W into, alright, for one problem that you should understand, minus this is 20 into zero point 0.5, which is equal to 10. Acting downwards, it is negative, minus 15, minus 15. Always you should know when there is a momentary couple like this 20 kilonewton meter, it is equivalent to two forces acting like this. This is the 20, 10, for example, 10 into 10 separated by a distance 2. This is equal to 20 kilonewton meter. So these two forces are, one is acting upwards, one is acting downwards. The total effect is equal to 0. Therefore, this moment will not come into picture when you take summation of forces. Also in shear forces. Okay. Next, I can write this as RA is equal to RA is equal to 25. RA is equal to 25 kilonewton. 25 kilonewton. This I will indicate by 25 kilonewton. RA. Okay, this is RA. Next, summation of moment about point A is equal to 0. At point A, there is a moment MA. Summation, there is a moment, all the moments I should consider. And also at the point, there is moment MA. My clockwise moment is positive. Clockwise is positive. Anti-clockwise is negative. And MA is anti-clockwise minus MA. This 20, this 20, this is clockwise plus 20 into zero point 0.5 is the load, okay, force into W into x by 2. This is the this center here, this is concentrated here, 20 into zero point 0.5, x by 2 is 0.25 plus zero point 0.5, okay, clockwise moment is positive, plus 20, okay, plus 15 into zero point 0.5 into zero point 0.5, this is 2, this is equal to 0. Tell me what is MA. How much? How much is MA? Just tell me. Calculate and tell me. Yes. How much is MA? How much? Raghavendra, how much? How much?
Sir, 57.5.
What about others? Why you are not talking? Abdul Razak, Dhruti, Mekala. I don't want to take the class. That's it. I will wind up here itself. MA, which is equal to what is the sign? Positive 57.5, right? This is 57.5. Since this is positive 57.5, whatever the direction which you assume is the same. Okay, whatever the direction we have assumed and whatever the value we have got positive 57.5. Therefore, this is correct. Okay, the sign what we have assumed and then the direction what we have assumed is correct. Hope you understand this. If instead of this, this is a minus 57.5, then I would have been taken my MA in the clockwise direction like this. But since I got 57.5 as positive, this is my MA is acting in the same sense as what we have assumed. Okay. Portion AB, x greater than or equal to 0, less than or equal to zero point 0.5. I will take portion A. The figure for this is like I will take this, I will write like this. A, I will not take up to B. I will take a section between A and B. This is A and B, and this is instead of this I can write like this. I can write RA which is equal to 25 and moment in the anticlockwise direction 57.5 section XX. Okay. Now for shear force, it is equal to sum of vertical forces, sum of vertical forces, and this is the section for me xx. If the force is acting upwards, this is positive. Shear force is positive. The shear force is towards right. Section is towards right hand side. Force is acting towards left hand side. This is the positive sign convention. If the force is acting downwards, and if my section is here, and this is acting on the right hand side upwards, this is my negative shear force convention. So in this case, force is acting upwards. This force is acting upwards. 25. Therefore, this 25 moment will not contribute to shear force. Therefore, F is equal to 25 kilonewton. Okay. Next, moment is equal to summation of moment about the section that is xx. Therefore, which is equal to you should assume that you should think like this. You should think like this. My uh, if this is the beam, if the beam is bent like this is clockwise, this is anti-clockwise, this is section xx, this is negative. If the beam is bent like this is anti-clockwise, this has to be clockwise. This is my section, this is my positive bending moment. Okay. Now bend. See, when I apply a force, this about this section, it will bend like this. Therefore, it will bend. Assume that it is bending like this. It means to say it is causing the sagging. Sorry, hogging. Therefore, this is negative. This is negative. It beam will bend. Assume that it is like this. This is negative. Therefore, it should be minus 25 into x minus 25 into x. This distance I have to call it as x. Sorry, I forgot to write. This distance is x. You cannot take this 0.5. In between that, I have taken a section. You can call x1, 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 x1. Next, I will take x2, x2. Minus 25 into x, and then you can see this moment is acting in the counterclockwise direction. This is like this, like this. Therefore, this is like this. The suction is towards the right hand side. This is the suction. Therefore, it should be positive 57.5. Okay. Sorry, how it is acting? Uh, Sorry, this is negative, sir. This is positive. This is negative. This is smiley face. This is sad face. Therefore, this has to be minus 57.5. This is towards the section. This is hogging. This is minus 57.5. Now, m at x is equal to x ranges from 0 to 0.5. X is equal to 0. M is equal to 0. M at x is equal to zero point 0.5, which is equal to minus 12.5 minus 57.5, which should be equal to how much? 58, 60, 70, minus 70, right? Correct? Huh? Sorry, I made a mistake. Give me a moment. 25 is acting like this. It will bend. This is positive, right? This is a smiley face. Sorry, initially there is a small little confusion. So give me a moment. I'll correct it. This is our smiley face. This has to be positive 25. This has to be positive 25, which should be equal to minus 45. Minus 45. I made a mistake here, hence this is also a mistake. Therefore, in the bending moment diagram, you should plot as soon as you plot. See here in the force term, there is only constant value. This is constant. Whereas in the bending moment term, there is a linear term. This is linear. When the shear force is constant, bending moment is linear. You should indicate there. You should indicate it here. Okay. I'll write one more sketch for shear force and bending moment diagram. One below the other should be draw a line for shear force diagram, horizontal line, bending moment diagram, one more horizontal line, indicate the points A, B, C, below the same points E, F, A, B, C, D, E, F. This is shear force diagram. This is bending moment diagram. This is load diagram. Okay. From in the region A, in the region 0 to 0.5, shear force is constant 25 kilonewton. 25 kilonewton. Bending moment is linear. I'll come to this. Shear force is constant 25 kilonewton from A to B. That is A to B 0 to 0.5. There is no variable. This is 25 kilonewton like this. A to B 25 kilonewton. Okay. This is constant. This is constant. Next, from for bending moment bending moment at x is equal to 0 is equal to 0, at x is equal to zero point 0.5 is minus 45. Okay, this is linear. Bending moment is linear. Since there is x term, this is linear. Okay, this is constant, this is linear, 0 and minus 45. At x is equal to 0 is equal to 0, at x is equal to zero point 0.5, at this point this is minus 45. I will indicate here minus 45. I will indicate it here. Below this axis, below this line beam, this is the beam, below this line is negative minus 45. This is constant, this has to be linear, like this, linear. Okay, next. Next, I will take portion x greater than or equal to zero point 0.5, x greater than or equal to zero point 0.5, less than or equal to 1, right? X greater than or equal to zero point 0.5, less than or equal to 1, and the figure will be, this is very important, you should understand. If you understood one problem, all the problems are same. Is the reaction force 25, there is a moment 57.5, and then there is, I will not, when I say suction, this is segment BC. When I say segment BC, I will take a suction, I have indicated this, I will take a suction, this is my suction x2, x2, this is my suction. Don't worry about the length, x2, x2. This is my point A. This is my point B. This is at the distance of zero point 0.5, and there is a UDL like this. UDL like this, which is equal to 20 kilonewton per meter. Okay, now this is at a distance. From one end we are considering the shear force and bending. One end we are taking the algebraic sum of forces and moment. From one end we are taking, so I will indicate this distance by x. Now now if this is x, if this is x, and this is zero point 0.5, this is zero point 0.5, can I write this as 25, 25, 57.5, A, B, zero point 0.5, this is zero point 0.5, from year to year, so year to year, this is x2, x2, this is x, this is x, sorry, this is x, then the x minus zero point 0.5, this should be x minus zero point 0.5, right? X minus zero point 0.5. Moment is equal to force into perpendicular distance. Force is 20, this is x minus 5. At the centroid, 20 into x minus zero point 0.5 is the magnitude. 20 into x minus zero point 0.5. Okay. Now, for shear force, F is equal to summation of forces in y direction, which is equal to, from the section, force acting upward is right towards the left hand side is positive. This suction acting downward, this is negative, and then the bending moment, this in anti-clockwise, clockwise smiley face is positive, and then if the moment is acting counterclockwise and clockwise from the suction, this is negative. Negative. Okay, summation of forces in y direction. This is 25 acting upward. This is the suction. X6 is x2, x2 is here. Force is acting upward. This is 25. Then there is one more force. This is this force. This is acting downwards. This acting downwards from the suction is negative, minus 20 into x minus 0.5. Okay, F at x is equal to x changing from, when there is a UDL for shear force also, the linear terms comes into picture. Also, if there is a linearly variable load UDL, then quadratic terms comes into picture. F at x is equal to 0.5 is equal to 25. This 0.5 cancels and 25. F at, sorry, let me write. Okay. Uh, 20 into F at x is equal to 1, which is equal to 25 minus 20 into 0.5, which is equal to 25 minus 20 into 0.5, which is equal to 15 kilometer. 15 kilometer. Hope you can understand this. Okay. Next, bending moment. Bending moment. This is shear force. Bending moment. Moment. Bending moment is summation of moment about x. This is very important. Moment is equal to, shall I write, this is acting upwards like this. This is acting from this section. This is causing smiley face like this. This is bending like this is smiley face. 25 into x. Okay, there's a downward force. We should consider downward force. Moment is equal to force into perpendicular distance. Force is 20. This 20 into 0.5 is the force. Since I am taking the section xx here, this distance has become x minus 0.5. I neglected this distance. This complete distance is x. X minus 0.5 is this distance. Okay, this is causing your, if I consider like this, it is causing anti-clockwise moment. Hence, this is suction is here, and the moment is like this, like this. This is causing, this is as similar to this anti-clockwise moment. Therefore, minus 20 into x minus 0.5. This force we have taken into perpendicular distance. Perpendicular distance. This is x minus 0.5. This would be x minus 0.5 by 2. Half of that is x by 2. Similar to that, this is equal to x minus 0.5 by 2, which is equal to 25x minus 10 into x minus 5 the whole square. M at x is equal to zero point 0.5. This is, sorry, point, this is 0.5. X minus 0.5 the whole square. M at x is equal to 0 is equal to how much? 25 into, this will be 0, right? 25 into x in minus 10 into x minus 0.5 the whole square. Yes, sir. M at x is equal to 0.5. It should be equal to 25 into 0.5. How much it would be? 12.5. 12.5. Okay. Correct? Huh? Anything wrong we have done? 25x once. Okay. Have I left anything? This force we have considered. This we have considered. Give me a moment. Okay. I have forgotten this moment. This moment I have forgotten. This has to be, I'll write it here. This has to be, this is acting like this. This has to be minus 57.5. This is causing like this. Suction is here. This is like this. Minus, I should be very conscious while solving this problem. Don't deviate anywhere while solving this problem. Minus 57.5. Minus 57.5. Next class also I will continue. I'll complete this problem. 12.5 minus 57.5 is equal to 45. Next, I will write, I don't have a space here, I'll be writing it here. M at x is equal to, this is 1, M at x is equal to 1 is equal to 25 minus 10 by 2 minus 57.5, which will be equal to 20 minus 57.5, which is equal to how much? Sorry, 25 minus 10, this is 5, this is 20, Nana. 20 minus 25 minus, have I done anything wrong? 25 minus 20 into 10, 20 by 2, 10 into 57.5. This will be how much? 23. M at x is equal to ranging from 0.5 to, this is ranging from 0.5 to 1. 25 into 125 minus x. This term will become 0. This term will become 0, right? This term will become 0. This is 0.5. Don't worry, I'll make you understand. Don't worry. For time being, we'll look at this. 25, this is 0.5, this will cancel. 12.5 minus 57.5, which will 25 minus 57.5, which should be equal to 35. 35, how much? 12, mistake ಆಯ್ತಲ್ಲಮ್ಮ. M at x is equal to 0. We got minus 45, this is minus 45. Minus 45. Minus 35, this is correct. Minus 35. Okay. Now, in order to practice, this is very simple. Once if you understood this is very simple. So, in order to practice, next step you will understand. I have made there is little constraint for space, that's why it has become jumbled. So, in order to plot this shear force, there is a x term in the shear force. Shear force is of magnitude 25 kilonewton. Load is constant here. Load was 0. Load is constant here. Therefore, shear force should be linear. Shear force should 25 kilonewton. From that point, it should be from let me write. Shear force at x is equal to 0.5 is 25 kilonewton. X is equal to 1 is 15 kilonewton. 15 kilonewton and 25 kilonewton. Let me call that. Shear force at x is equal to 0.5. At x is equal to 0.5, this is 25 kilonewton only. At x is equal to 1, it is equal to 15 kilonewton around here. 15 kilonewton. Since this is a linear, it should drop like this. 15 kilonewton. 15 kilonewton. Okay. Bending moment. Bending moment. Bending moment at x is equal to 0, it's minus 45, and at x is equal to 1 is minus 35. And see here there is a quadratic term here, 10 into x minus 0.5 the whole square. Okay, x minus 0.5 the whole square. Therefore, this will be a quadratic term. Okay, minus 45 and minus 35. Quadratic term. Always you should see. It is minus 45 is this, minus 35 mark here, minus 35. And see how the shear force is. Shear force is like this, like this. You don't know, since this is a negative quantity, negative, the curve can be like this only, C2D, or it can be like this, C2D. It is like this. Two options are there, like this or like this. But we don't know which curve. I'll go back and check it out. I'll go back and check it out. Negative, how was this shear force? Shear force was like this. Shear force was like this, in this, like this, 25 to 15. Therefore the curve has to be like this. Therefore the curve has to be like this, right? How was the shear force? Shear force was positive 25 to 15, positive 25 to 15, like this, like this. Therefore the curve will be like this, like this. One problem you answer. Next problem only. Bending moment will be the curve like this. 25 to 30, curve like this. Okay. Next, the next link I will be sharing with you. These problems are easy. First problem might feel little difficult. I will also take little time. Next problem onwards will come to know. These are very easy problems. Okay. I'll share the second link. You join with the second link. And I'll be sharing now. You can join now itself. Okay.